Welcome to Algebra 2 with Mr. Clausen. Today I want to talk with you about how to find the length of an arc. And specifically what we're going to look at is how to measure the length of an arc in a circle and then tackle a couple real-world scenario type problems in this specific video. So with that said, let's get started here. So one thing that you all know about measuring things like arcs is that an arc is just a portion of a circumference. So most of you probably know that if you go and you look at a circle and you go 360 degrees all the way around that circle, you know that you can find circumference C of that circle by going 2 pi r, where r is just simply the radius of the circle and 2 pi is the circumference. So if you have something with a unit of 1 inch and you want to know the circumference of that circle, it's just 2 pi inches for the entire circumference. So what we're going to do is we're going to use that same knowledge here for measuring an arc, but we're only going to look at how to find the length of just a portion of a circle. And so we're going to use that information to find a portion of a circle. So for example, if you want to find the length of the arc for just this part, this would be referred to as S in terms of the general arc formula that's in a standard Algebra 2 textbook. And as long as we know the angle theta and the radius of the circle r, we can find this arc length, or vice versa. So if we look at an example like this one, let's say we have a circle where the theta angle here of this is, I don't know, let's say it's 60 degrees just for the sake of an example. And then we know that the radius of the circle, let's say, is 20 centimeters. And we want to find the arc length of the circle given this angle theta and this radian and this radius. So with that, the only thing you really need to do in this given instance is, instead of going 2 pi for the entire circle, all you need to do is multiply by the theta value for the portion of the circle that we're looking at instead of 2 pi. So it's going to be some fraction of 2 pi. And the way that we do that is, instead of using a degree value for arcs, we always use radians, right? So if we're watching the last video and you saw my bonus scale and you're like, well, when do I use degrees or when do I use radians? You use degrees whenever you want to find an angle, and you use radians when you want to find an arc. That's kind of the simple delineation I'm going to give you right now. So since I'm trying to find an arc, S, in this given situation, and I want to use this formula, theta has to be in radians. And since I have this in degrees right now, the first thing I'm going to do is I'm going to convert this to radians. So I'm going to divide 60 by 180 degrees over pi. This will give me pi over 3 radians for the radian value of 60 degrees. And so if I want to find the arc length S for this given arc, S would simply equal the radius, which is 20 centimeters, and I would write the units here if it's given to you in a problem, and then simply multiply it by the portion of the circle you're looking at. We're only looking at pi over 3 of the 2 pi of the circle, because if we went pi over 3 6 times, we would have the whole circle. So we're just taking that portion of the entire circumference, and we would find that the circumference of the circle is 20 pi over 3 centimeters for its arc length. And if you want it in like the nearest hundreds or thousandths, depending on what the problem asks you, you can just simply take it, you can plug these values into your calculator, and then you would find that the actual circumference, I guess to the nearest hundredth, let's say, is 20.94 centimeters. And you can do that as well. And so given on the situation or circumstance here, we can find some of these given values. And we can do the same thing here. Let's say, for example, they want to know the area of this portion of a circle. And so they tell you that, that the angle from here to here in standard notation is, let's say, 30 degrees. And so they want to know the arc length of this guy right here. They want to know the arc length of most of the circle, just minus that 30 degrees. So we can apply the same knowledge. The first thing that we need to do is that we need to find theta for this entire thing here. So this will just be the coterminal angle to the 30 degrees here, so to speak. So this will be the 360 minus 30. And so the standard angle would just be 330 degrees. And normally I'm thinking about this in degrees and not necessarily the radians, unless I'm kind of teaching it and I'm in it. But there's nothing wrong with finding the degree value and then converting it to radians. So if I want to find this specific arc length right here, this specific S value, then what I'm going to do is I'm just going to do the same thing I did before. We could do it all in the same problem. Ooh, I need to pick a radius value. I think the radius I wanted for this problem, let's say 100 inches. And so if you want to find the length of this in inches, you will be given a radius in a problem. But let's say the radius is 100 inches. And then if I want to find the circumference or the arc of that portion of the circumference, then all I would do is take the 330 degrees. And I need to convert this to radians. So I'll go 180 degrees. And what I'll find is that when I do this conversion, I'll find that the value is equal to 11 pi over 6. And this is the thing you really have to remember with arcs, is you have to do it in radians or it's not going to work. And so now if I want to go and I want to find the arc length, it's generally pretty easy. I just take my radius, whatever is assigned in the problem, multiply it by the radian value. And in this given case, I would have 1100 pi over 6 inches. We could go and say 550 over 3 pi inches technically, and that would be a simplified form of this answer. Or maybe they ask it for this given value in the nearest decimal. So let's take this and multiply it by the pi value here and see if we round it to the nearest hundredth of an inch, it would be 575.96 inches. Okay. And so really when we're finding arc lengths, we're just looking at a portion of a circumference. And you can think about it that way. And if you're ever looking for the circumference of a circle, you understood that it was 2 pi r. So we're going to do the same thing, except we're going to just find the portion of 2 pi that we are targeting. And so this is a few different ways that you can look at this given circumstance. So with that said, let's just analyze some basic real-world problems. So if we have a slice of pizza and you want to know the length of the crust in terms of the arc, right? You're given angle theta, you're given a length of inches. You just use the formula. The only thing we really need to do with theta is do the same thing we did before. And I guess I picked the same angle I did before. Didn't really intend that, but let's just convert degrees to radians like we did in the previous lesson. Get pi over 3. Have our radius of 8 inches. And if we want to find our arc, we just take that 8 inches. We multiply it by pi over 3. And therefore, the arc length of the pizza crust will be 8 pi over 3 inches. And if we go and we do a little math on that, we would find that this is equal to 8.378 inches in length. And that would be your arc of your pizza crust. So let's step it up a little bit, and then I'm going to let you go with the rest of this. And the example that I have here is looking at a clock. So this is a clock that's in Brazil. And the clock is a 24-hour clock. So this is very common in other parts of the world outside of the United States. And so what you'll see is that we have all these markings for each hour of the day. And then with the inside hand, we have some different minute readings for each hour. And so if you want to look at something like this, and we want to understand like the arc length, let's say from here to here, or maybe here to 4 hours, all right, we can find that given value. But to really get started with this, we need to find the angle measure between each hour of the clock, and let's express it in exact radian measure. So the easiest way to do this is understand that the whole circle, the whole circumference of the clock is equal to 2 pi. And so if you need to find a portion, an equal portion of each hour represented by this clock, if we need to know that portion, that portion, and that portion, then they're all equal measured portions, you just take the circumference of your circle and you divide it by the 24 equal portions on this clock. And we're just taking 2 pi and dividing it by the number of portions. This is the entire circle. And this is the number of portions that we're trying to divide it by. And so if we need to know how many portions that we need, so if we want to know the exact radian measure of one of these portions, we just go and we simplify to, goes into 24 12 times, and we know that pi over 12 radians is the radian measure of 1 hour. And this is really useful for us because now let's say we're looking at this clock and we want to know the length of the arc form after 4 hours. So we want to know the length of this arc. And so what I'm going to do, I'm going to treat this as S for our given situation. They tell us that R is equal to 30 centimeters. And we want to find the length of that arc after 4 hours. So we just take our 1 hour measurement that we did in the previous step. So this is pi over 12 per hour. We'll multiply this by 4 hours. And so what we would find is that after 4 pi over 12, that is the length that is traveled in that course of time. And oh look, I guess pi over 3 was just on my brain today. So that is the length of that arc, which you would also know is equal to 60 degrees if you were paying attention earlier. And so this is the radian measure for the 4 hours that we're looking for. And so if we want to know the length of that arc given a 30 centimeter hand of the clock, what we're going to do is just say the arc length is equal to 30 centimeters times pi over 3. And what we'll find is that, well, 30 divided by 3 is 10. So 10 pi centimeters is the arc length of the clock. And if we want to know that, just maybe in decimal form maybe, or to the nearest centimeter, it would be 314 centimeters would be the arc length of that clock. Now, they also ask another question. They say, if the minute hand is 24 centimeters, what is the arc formed after 45 minutes? Well, we see 45 minutes, if we're looking at it here, 45 minutes is equal to 18 hours on this clock. So you could go and figure out what the radian measure should be, or we could just use the value that we found before. All right, and if we want to figure out how far the arc is made by the minute hand, which goes from here all the way around, back up to here, and we want to find that arc length, well, we need to find that theta value. So pi over 12 is equal to each hour. The 45 minutes is equal to 18 hours, at least in terms of theta, not necessarily the arc, because the arc length is a little bit different in how we're going to measure it because the length of the minute hand is shorter than the length of the hour hand. But if we take that and multiply it by the 18 hours that's here, we see that 18 pi over 12 is going to be our theta value. We'll see that this is equal to 3 over 2, 1 simplified, because 6 goes into 18 3 times, 6 goes into 12 2 times. As I've mentioned before, you have some really awesome fraction converters like in your calculator, in a TI-84 emulator or those type of things, and I can show you how to do that in class if you need me to. But what we're going to do is just simplify this to 3 pi over 2, and that's our radian value. Our radius is 24 centimeters, and so if you want to find the arc length, it's just 24 centimeters times 3 pi over 2. I'm just going to keep the math simple. This will equal 36 pi centimeters, and we would be done if we wanted it in pi in terms of the units. If we need to go and do a little math on the units, it would just be 36 times pi, which is equal to 113 point, let's say 10 centimeters. And then you would have the arc length formed by the minute hand going 45 minutes. All right, so hopefully with this video you got a grasp on how to determine the arc length of a circle. And with that said, let's do some math.